So today we're going to be talking about proving quadrilaterals or parallelograms. So this is going to go back to our doodle notes where we filled in parallelograms, and I just filled this one out by hand. So let's review those properties, because these are the properties of a parallelogram. So for proving a quadrilateral is a parallelogram, these properties need to be, one of these properties are going to be used to prove that they're a parallelogram. So if we can prove that there are two pair of parallel sides, then we know we have a parallelogram. We can show that the quadrilateral is a parallelogram. Okay, so if we could prove that these have two pair of parallel sides, then it's a parallelogram. If we could prove the opposite angles are congruent, so if I could prove this angle and this angle are equal, and this angle and this angle are equal, then I know I have a parallelogram. If I have one pair of sides, and this is just one pair, that are parallel and congruent, so both of these conditions exist, they are parallel and congruent, then I know I have a parallelogram. Okay, if I can prove my opposite sides are congruent, okay, if I can prove those two are congruent, then I have a parallelogram. If I can prove the diagonals bisect each other, if I can prove these two pieces equal each other and the other two pieces equal each other, then it's a parallelogram. And the consecutive angles are supplementary. So if I can prove these two add up to 180, or these two add up to 180, there are four sets, those could add up to 180, and these add up to 180, then I can prove that it's a parallelogram. So what is this going to look like? So, are we given enough information to determine whether the quadrilateral is a parallelogram and explain? So the explain part, that's going to go back to these properties. Which one of these properties apply? So on my first one, I'm noticing that I have a pair of parallel sides, and that side is congruent. So, my answer is yes. This is a parallelogram. Why? Because I have one pair of sides, they're congruent and parallel. That's the symbol for parallel. It's two slants next to each other. So yes, because one pair of sides is congruent and parallel. Okay, if I look at the second one, so I'm looking at the markings here. I see I'm obviously looking at my diagonals. So my diagonals, let's see, they do split each other in half. They split each other in half. So does that make it a parallelogram? Yes. Why? The explanation, the diagonals bisect each other. That's the property. The diagonals bisect each other. Okay, what about number 3? I'm looking at markings. So I see this pair of sides are congruent and this pair of sides are congruent. Does that make a parallelogram? Yes, it does. Why? Because opposite sides are congruent. Opposite sides are congruent. That's the symbol for congruent. Equal sign with a squiggle. Okay, let's look at the next one. So I see I have a pair of parallel sides, and I have a pair of congruent sides. Okay, well, I know we used this one, but they were both on the same set of sides. One pair, congruent and parallel. Okay, well, now I have them on different sides. So we don't have a property for that one, so that's a no. we do not have a parallelogram. Okay, so we do not have both set of parallel sides. Or congruent, or one pair, congruent and parallel. Okay, so there's a bunch of reasons. Either I would have to have both sets of parallel, both sets of congruent, or I would need one set parallel and congruent. So that's a no. Oh, let's see. There's so many different ways I could do number 5. First off, I see congruent triangles because I have an angle, another angle, and then they share that side. That side is reflexive. I could also use the alternate interior angle converse. If you have alternate interior angles, then you have parallel sides. So that tells me I make that Z shape. That tells me those are parallel. And I have another Z shape. So that tells me those are parallel. That's going to depend on which one you choose. So this is definitely a yes, but it's going to depend. Why? Because like I said, I have angle, this is reflexive, this is an angle, so there's my side angle. And since my triangles are congruent, that means all the other parts are congruent. And I would have opposite sides congruent by congruent triangles. Actually it was angle, side angle, and CPCTC, corresponding parts of congruent triangles are congruent. Okay, if I choose a different color, I could also say, okay, here, here, and here. Those are alternate interior angles. Alternate interior angles mean I have parallel lines. And then I can go the opposite way. Make a Z. And I can prove that these are parallel based on the alternate interior angle converse. So I could also have a yes. That would be 2 pair parallel sides by angle, alternate interior angle converse. That would be the converse. So that would be my explanation. Yes, anything that we've used in the past can apply. So we proved triangles were congruent, and we've had parallel lines cut by a transversal before as well. So all of that applies, anything we can use. Okay, so number 6, is it a parallelogram? Let's see. It said supplementary angles are consecutive angles are supplementary. So I could take a look at 60 and 120. Those add up to 180. So those are supplementary. You could also take these two. Those are supplementary. Let's see. We now know that a quadrilateral adds up to 360 degrees. So that makes this angle 120, which makes these supplementary and makes these supplementary. So that's a yes. And that's because the consecutive angles are I lost my S. Consecutive angles are supplementary. And I'm going to run out of room. We barely got it in there. Okay. Now, throwing some algebra in there. Determine the value of x and y so that the quadrilateral is a parallelogram. Since I'm given the sides on this first one, and I have an x and a y mix, so I don't want to do that first. Ooh, here's a single variable. If this is a parallelogram, what would I know about these two sides? They should be equal. They should be congruent. So that sets up my equation. See, I know parallelograms, opposite sides have to be congruent. So I'm going to set that up, solve for x, 3x equals 6, x is equal to 2. Now I can substitute that 2 in here. So now I get 2 plus 2 equals 4. Okay, so now I know my top side is 4. That means I can find y, because they should be equal. 4 equals y minus 1. And then I solve for y by adding 1 to both sides. So 5 is equal to y. So those are my answers. X is equal to 2, because those two should be equal. Since x is 2, I can substitute it into this equation, and I get 4, and then I know these two should be equal. So 4 should equal 4 minus 1. Y minus 1. Okay, on my second problem, it looks like we're dealing with the angles, and there's more than one way to go. We could set it up opposite angles are congruent, so these two would equal each other, and these two would equal each other. Or we can set it up where the consecutive angles add up to 180. To me, I think it's going to be easier to do opposite angles, and I want to go ahead and start off with 2x and 70 because I see there's a y in this one. So there's an x and a y. So I would need to find x first. So these two I can't solve for one of the variables, but these two I can. So 2x equals 70. Divide by 2. My x is equal to 35. So that's what x would have to be. And then I know 3x plus 5 would have to equal x plus 3y. Well, I already know what x is. So I'm going to do 3 times 35 plus 5 equals 35 plus 3y. So 3 times 35, that gives me 105 plus 5 equals 35 plus 3y. I'm going to combine those, so that gives me 110 equals 35 plus 3y. Subtract 35, because I want to get the 3y by itself. And I get 75 equals 3y. Divide by 3, and my y is going to be 25. So that's what the y would have to be in order for this to be a parallelogram. Okay, so these are the type of things that you're going to have to do on the test. Okay, you're going to have to tell me what property applies, and you're going to have to tell me what x would have to be in order for it to be a parallelogram. Okay, now it's your turn to practice.